buongiorno. Pochi ma buoni, spero. Good morning, because I think I need to do the presentation in English. However, you can do questions, can make questions both in English and Italians. It's the same, okay? I'm here to introduce you to the master degree in computer engineering for intelligent systems. That is a master degree that started in a new form 1 year ago, but it has created some years ago with the new department of engineering for innovation medicine, the new engineering department at the University of Verona. We think that is a very interesting master degree for many reasons. The main topic of this master degree is computer engineering, of course, because it's a master degree in computer engineering, but as a particular flavor because it covers the technologies that are strictly related to what we call Industry 4 and 5.0 and healthcare 4.0. The course was started only with the industrial curriculum, and last year was improved with the addition of the healthcare curriculum, also because we have a department in which now we have both engineers, computer scientists, and medical doctors and working together, and we'll explain later. And in this course, we study the technologies that are related to what we call the digital twins, both of the industrial systems and healthcare systems that, of course, in this case are computer-based digital twins in which we try to replicate or simulate or facilitate the industrial and the healthcare tasks with computers, of course, using computer technology. And another keyword for our course is human-centered technology, because the idea, especially in the Industry 5.0 ideas, is to make technology application human-centered. That means that they need to be understandable by humans and made to help humans, not to replace humans. Okay, and the nice thing is that in the transition to this new world of applications of the industrial and healthcare domain, we know, because companies tell us this, and it's known to be true, that there is a strong need of new professional figures to apply these computer methodologies to the domains. So there is a need of a particular new kind of computer engineers that is able not only to master well the technologies, but also to have specific knowledges of the application domain. That means what is done in the industry and what is done in the healthcare, in hospitals, in telemedicine, and so on. So this means that what we aim to teach is a combination of skills that are not only the enabling technologies related to computer application, robotics, cyber physical systems, artificial intelligence, but also human-machine interactions, big data, and so on. But we have to combine this knowledge with skills and knowledges related to application domains. So, for example, in the industry, we need to know which are the typical data that are managed by industrial systems, which are the type of machines. So you need to have some engineering basics about the machines that are working in industrial applications. And the same for the healthcare applications. So we need to have a knowledge about the particular kind of application, the medical imaging techniques, digital technology for telemedicine, and so on. So it is a computer engineering master degree, but give also this context that is important to have better application of the technology. Okay. Okay. So the new title, the new name of the master degree that we gave after the introduction of the second curriculum, the one on healthcare, is computer engineering for intelligent systems, because we think that this definition combines what is found in both healthcare and industrial application that are intelligent systems. So what are intelligent systems and what we want to enable you to create? Intelligent systems are those systems that interact with the environment and human beings, and are in some terms autonomous and can help workers of different fields to complete their tasks. Okay, and this is typically now done also using strongly machine learning techniques. So, for example, system to assist doctors in operating rooms are intelligent system, typically system to assist workers in an industrial setting that is simulated there in our lab, because we'll talk later about the labs that we have are intelligent systems, and there are many of these systems that we need to develop to help workers, but also end users or patients for healthcare systems, or to improve the safety and the productivity of industries. Okay. So at the end, what are the professional figures that this master degree wants to train? They are in industrial and healthcare computer system engineering, and we stress the idea of this system word. And industrial computer engineers deal with the design, integration, and management of industrial computer systems that have, of course, a different level of complexity and distance from the physical layer of the real-world application. So we have to work with network infrastructures, sensors, robotic architectures, computational resources, IoT systems, user interfaces, and so on. And this specifically designed for the industrial application, so we need to have a specific, at least some kind of context information. And the same for healthcare computer system engineering, that need to deal with the design, integration, and management of systems for patient monitoring, hospital management, telemedicines, and so on. Of course, diagnostic imaging systems and image processing, and so on. As I said before, this master degree is inserted in a plan that lead to the creation of the novel Department of Engineering of the University of Verona, that now has a complete, as you probably know, has a complete set of courses, starting from 2 bachelor degrees, these master degree, and a PhD program that are both focused on the integration not only of engineering, but of engineering with also healthcare. Not saying that we are dropping industrial application, but we added this idea of putting together the idea of Industry 4.0 and Healthcare 4.0, because they are created, they are supported by the same kind of technologies, as we will see in a few minutes, looking at the program of also of the courses. So this means that this department has been created, putting together computer engineers with a large number of medical doctors that are now trying to collaborate to create also novel research projects, novel applications, and so on. So the main target of this department is healthcare 4.0 that exploits the previously existing knowledge about industry 4.0, 5.0, that we have from the computer engineering side to the applications in the healthcare. Okay, so as I talking about industry 4, 5.0 and healthcare 4.0, I just give a short reminder on what we mean. What do we mean when we talk about industry 4 5.0? Okay, it's known that there have been many industrial revolutions, changes of paradigms in the history of industry, starting from the introduction of steam power and machines, the first industrial revolution, to the second one with the introduction of electricity, chemicals, and oil, the industrial revolution related to the electronic automation in the early 70s. Finally, with our period in which we have the first big revolution of related to smart machines and smart systems, so what we want to make in our applications that are connected and are somehow autonomous and can collaborate with humans. And in the fifth revolution, that is what we are, it's ongoing, there is a bigger stress also not only in this intelligent application using AI, using interconnected smart machines, but also the idea that we need to also manage resources to have a sustainable production and having the human-centered application in which the goal is not to replace humans, but is to empower humans and to collaborate with humans. Okay. A similar process is ongoing in healthcare. Okay, so also in healthcare, the theoretical people that likes to make this theory about revolutions classified more or less 4 revolutions, in which the first is actually the beginning of the public health, actually, with the hospitals, vaccines, and so on. The second was related to the introduction of the pharmaceutical industry, antibiotics, bigger hospitals, and so on. And then in recent years, we have the introduction of computers and imaging, computer-assisted diagnosis, and so on. And now we are also applying AI, autonomous systems, both for diagnosis, but also to support surgeons in operating room. And we have also telemedicines, wearables, and if you think the same kind of technologies that we are using in industry. So for this reason, these 2 words are quite connected when we talk about engineering, computer engineering applied to the domain, because we are considering technologies like robotics, like artificial intelligence, like embedded systems, wearables, like virtual reality, 3D reconstruction, and so on. So the enabling technologies are the same. And for this reason, we focus in our course, if we come to the master degree, on teaching these enabling technologies that are the same in both Industry 4.0, the 5.0, and healthcare 4.0. So what is inside the study plan of our master degree? First, we have some basics exams on the most important topics related to, for example, data management, machine learning, okay? Yes, there is a word missing here. The second is data management and machine intelligence, because we have machine learning course as a basics, as well as programming, and specifically for focused also on architectures for intelligent systems, or also embedded systems and so on, high performance computing and so on. And also some basic knowledge about dynamic system, because if you need to study robotics, robotic system, we need to know some basic mathematics tool for doing this. And these exams are mandatory because are something that completes your bachelor knowledge coming from the bachelor degree. Okay, then we have the particular computer engineering technologies that are characterizing our idea of enabling technology for healthcare and industry 4.0, 5.0, that are, for example, that are characterized by these 6 courses in which you have to choose 4 that are focused on the topics that are the most important for the application, and are also the ones in which the teachers here have a lot of knowledge, because there are research groups very strong on embedded systems, on robotics, and on machine learning and computer vision, virtual reality, and so on. So we have these 6 courses, and you can learn advanced technologies that are used in industrial and medical applications, focusing on the subtopics that you prefer. If you are more interested in robotics or in machine learning and computer vision or on embedded system, you can choose the subtopics that you prefer. And this is the basic computer engineering and enabling technologies knowledge that we want to give to the students. Then we have the courses that give the specific knowledge related to the application domain. So we have 2 distinct curricula, one for industrial systems and one for healthcare systems, meaning that in this curriculum we have first a mandatory course that gives the background, the context. For the industrial curriculum, this course is called Industrial Plants and Production Management, and is a course in which you learn about what are the types of machine and how is managed in an industrial plant, for example, and the production in industrial plants and so on. Then there is a group of optional courses in which you still learn about computer technologies, but more focused on the application domain. So we have other courses, for example, related to robotics, system testing, networks, material science, cybersecurity, virtual extended reality, and so on. And you can complete your background of knowledges and skills, focusing on the application you prefer. You have to consider that all these courses are held by people working in research with connection with many companies, as we will discuss, and you can choose the path that seems that you prefer related to this domain. Of course, then there are other credits that you can complete with other optional course, and obviously you can complete or need to complete your path, your educational path with internships and thesis and the final thesis. And of course, you have a lot of opportunities in our department for doing both internships and thesis I will repeat it a bit later, with both research groups inside the university, because we have a lot of research groups active in both industrial project or European projects or research project with also international partnerships. So you can also go abroad with Erasmus, and there are a lot of opportunities. And there is also the possibility of doing internships with companies. Okay. The healthcare system curriculum is more or less similar in the sense that it's completely parallel. You have a mandatory course in which the context given is the context about healthcare related intelligent systems. So you will learn about medical data, management of medical data, digital technology, and you will learn also about the particular specific aspects of medical data, and also about digital imaging in medicine. And then there are optional courses focused on the medical applications. The particularity of these optional courses focused on the medical part is that some of them are also held in collaboration with medical doctors. So both we have, for example, medical robotics or neuroimaging courses, or courses on Internet of Medical Things that are held with collaboration also of doctors. And so you can see both the side of the application, the computer science part and the medical part. And this is particularly interesting. For the rest, it's the same. You have to complete then with other optional credits, and you have a lot of opportunities for internships and thesis with the different focus on also on research teams, on research groups. Okay. One particular strong asset that we have in this master degree and in our department is that we have, I said, a lot of research groups active in different aspects of industrial and healthcare application, and we have also labs. Okay, you probably know that we have this industrial computer engineering lab that is in Verona, near the fair, in which we have a lot of machines of different kinds. That we have transport line. All this is real, and you can do a thesis, or you can also have courses in which you learn this technology and you can work with these machines. So we have mobile robots, visual systems for quality control, vision-based quality control, systems to track the movement of people, systems, 3D printers, different kind of manufacturing tools, and we have everything in the lab. We have computer systems monitoring everything, the digital twin, industrial digital twin of the laboratory, and we have, I can see other part of the video here, and we have also the possibility of using virtual and augmented reality to interact with machine or to simulate machine. So we have also tools for this, and we have the possibility of doing a lot of learning activity there. This is for industrial part. For the healthcare part, we are going to have a similar demonstration lab, because it's not yet open, but it will open before the end of this year, in September, October, I think. And there has been already the presentation in which we have demonstrated the technologies that we will showcase in this novel lab, and that are the application of IoT technologies to healthcare, machine learning, and AI, to neuroimaging, or to image analysis of different kinds of digital pathologies, telemedicine, virtual reality for visualization of medical data. All these technologies have been already demonstrated, because it's something that is related to the research projects in which we have involved as researchers. And we will have a dedicated lab that will be the one corresponding to the ICE lab for the industrial part. Okay, so I think that we have a lot of there are a lot of interesting reasons for joining our master degree. As I said, there is the possibility of doing thesis or internships with also companies, and we have a lot of collaboration with different companies that also suggested us how to organize the course, and there are a lot of ongoing collaborations and a lot of research activities, as I said, because we have different research groups active in embedded system, medical robotics, telemedicine, robotics for industry or agriculture, visual computing applied to different application domain for design, fashion, and so on, quality control. We have different researches on human-computer interaction, also considering extended reality and virtual and augmented reality. So we have a lot of research activity with ongoing research projects in which you can collaborate, you can be involved, of course, because many students do thesis works or internships related to research projects. Okay. Okay, I didn't ask you to interrupt me, but if you have a question, you could. Okay, I've nearly finished, but if you want to interrupt me before the end, you can, of course. But more or less, I completed the presentation, and I conclude the presentation talking about the requirements. Of course, this is a master degree, and there are some requirements for enrolling that, however, are standard for computer engineering courses, in the sense that if you are an Italian student, you should have, it's obvious that you think that a degree in the information engineering class, it's okay, and it is okay. Of course, you don't have to study anything else. But in any case, you can join even if you have another kind of 3 years degree, even if you have a degree in computer science here in Verona, you have the requirements, you should have the requirements probably for joining, because the minimum requirements is that you have at least a CFU obtained in these same sectors, scientific sectors, that actually corresponds to having a solid background in mathematics, computer science, engineering basics. Okay, so it is obvious that to join this kind of master degree, you need to have this basis. And if you have this basis, or a master degree, yes, a bachelor degree, if you are an international student, if you have a bachelor degree in electronic engineering, computer engineering, in computer science, typically you have sufficient background. If you have an engineering degree, you need at least to have some courses on computer programming and so on. If you are a mathematician or computer science scientist, you need to have at least some basics engineering course, but most of the bachelor degrees have these basics. Okay. Of course, the course is in English, and so this means that Italian students or both our international students need to have a certifications that is B2, okay, that you can also obtain before the completion of the application process. So you don't need to have immediately, but you have you need to have the certification before the completion of the application process. Okay. And that's more or less all. And of course, if you have any question, you can find, of course, a lot of information about the course, and you have already seen it on the website. Okay, this is the address of the website. If you have any other question, that of course, if you have questions now, you should ask me immediately. If you come up with questions later, you can come in my office or write me an email at this address, Andrea Giacchetti, University of Verona. And or if you prefer, you can also write to the other people in the AQ commission of the master degree, or contact any other teacher. Okay, that's all. Thank you for the attention, and please, I'm open to questions, and from here or for people remotely. I see that there is some people listening. So if there are questions, please ask. I will try to answer as. Okay. When in the few minutes in which I will wait for questions, hopefully that I will put the video about another video about our master degree and our lab that explains the technology. If you don't have question, I will let you see the video or put the audio in any case. Any question? Yes, please. No, si può cambiare, si può scegliere, non è un problema. E no, il corso è obbligatorio, di curriculum sono già al primo anno. Però allora, per come è organizzato adesso, credo che ok, I can say in English. There are mandatory courses related to curriculums. I think that already in the second semester of the first year, but I think not in the first semester. So you can change, but it should be in this way now. But there is a possibility that some courses are changed in semesters, but. At the moment, I think that the mandatory courses are held for the curriculum are held in the second semester. But of course, it's better if you decide immediately. But you can change then. It's not an issue. Other questions? No question? Because you are not interested, or because I was so much clear that you don't need. Okay. Repeating. Okay. If we are out of time, I can stop. Okay. Direi che possiamo fermarci. Ok. Any other question? Domande? No. Ok, grazie per l'attenzione. Finisco qua. Speriamo di vederci in futuro. Grazie. Allora, qua.